Welcome, ladies and gentlemen, to another edition of Binary Life, and today we'll be solving everything that has to do with liveness probe and readiness probes on Kubernetes. So let's try to solve these lab on the Kodekloud.com, which is a platform that has a lot of practice exercises and tutorials for your DevOps system admin Cs and cloud development. So let's start. So we have deployed a simple web app, inspect the pod and services. I think it's something like this. We can get also, we have these are the services here. These are the pods. We have two services and one pod. I can say in all namespaces like this. So we have this is how you see everything in the Kubernetes cluster. So these are all the namespaces. We have the default namespace here. When we say we had one pod up there, that was about the default namespace. You see a simple web app. And this is the kube system namespace. This is reserved for Kubernetes. And we have two services just like we saw up there under the default namespace. It's two services. And that's it. Alright. We have also under the namespace here, we have node deployment. All the deployments here and daemon set and replica set are all Kubernetes. They are all in the Kubernetes namespace. Okay, so we've inspected the pod. Okay. So view the application by clicking on the web portal tab. So we have the web portal tab here. Let's click on that. Hello from simple web app. Right. Okay. Next question. A test script is provided that sends multiple requests to access the web application. Execute the script at this. So we should have a curl script somewhere. Let's just see ls. The script is here. Let's take a look at what's inside. Curl test. So it's a for loop that loops 20 times from 1 to 20, and 20 times what happens? kubectl exec, it connects to this namespace, to this pod. I think this is the name of the pod here. So the curl pod. Let's see what pod do we have again. kubectl get pods. Now let's get the pods in the namespace kube public. What are the pods there? -n. Right, so we have a curl pod running here. So this command connects to that pod and executes a shell command, which is wget. Wget is like a ping test, like try to send a get request to probably a web service that's running inside that pod on port 8080. And if everything is okay, it returns test okay. If not, it returns fail. It does that 20 times. Okay, so let's execute that script. So we can see that it's okay. We're going to see this message like 20 times. Okay, so let's see. Okay. Now we just created a new pod to scale the application. kubectl get pod. It should be simple too, because before that I did this get pods. We had a web app 1, so now we have a web app 2 here. So run the script again. Why do I need to run the script again? What has changed? Let's see what's inside again. What is the same script? It's the same script. So let's just run it again. Now it has failed, and then it works, and then it fails at the same time. Okay, so I'm guessing that anyway, let's not guess, let's just continue. Application takes 80 seconds to warm up. We'll have to wait for 80 seconds and run again. Okay, everything is okay. It looks like it's almost getting better. Some are failing, some are not, some are passing. Let's just see. Okay, we'll discover ahead, I guess. So now notice the errors in the output. That's what we just saw here. Okay, now update the newly created pod, a simple web app tool with a readiness probe using the given spec. So kubectl, let's get a list of pods. So let's get the simple web app tool and put the output in a YAML file, and let's call it web app tool.yaml is get pod. So let's edit the file and add readiness probe under the container spec section. Readiness probe. Under the readiness probe, we send an HTTP GET request to the port 8080 and the probe. I don't know if it's written probe. /ready. Let me check the syntax on the Kubernetes documentation. Let's look for readiness probe. This is liveness, so it's actually path. It's the same thing like this is, we have to put path instead of prop. So let's come back to the exercise, and this will be path. Okay, so let's save, and we need to delete the pod. kubectl delete pod and recreate it from our configuration file. Oops, it's deleting. It's taking a while. Looks like it's slow. Okay, so now let's create a new pod from the edited file web app to, and let's test the code. It's okay. And let's rerun the script. So right now we're hitting just web 1 because web 2 is not yet ready. So it's until it's ready that this is going to make a CKAD request. If we go back right up, I'm sure that everywhere it was failing was because it was hitting but simple web app 2. Okay. So I'll wait for the new pod to be ready and run the test again to see traffic distributed between the pods. Normally we have to wait for like 80 seconds because that's the readiness prop configuration. Execute the script again. Let's check the state of the prod. Oh, connection is gone. Reconnecting. Okay, let's recheck the state of the prod of the pod. Here we get pods. It's running. Let's rerun the script again. The CKAD test. So now traffic is being distributed between 1 and 2 and everything is okay now. Remember, let's look at what is inside that curl file again. It connects to the curl pod, but according to this file we can see that actually the curl pod is a pod that makes curl requests to this web app service. That's these 2 pods here. So when we run this, it actually tries to tap into this service configured into this application configured into this pod. So now we have configured 2 single web app pods. So the apps are inside these 2 pods, so traffic is distributed between them. Okay. What will happen if the application inside the container on one of the pod crashes? Try it by accessing the crash script. What's inside the crash script? Let's see what's inside. So the crash script connects to the curl pod and executes this crash endpoint. So there should be some code there that permits the application to crash. So let's run that code. It's crashed. How do we see if it's crashed? Let's just see if we run the state of the pods. It has restarted, so it has actually crashed. So we can even look at the description to see if we have extra information. Describe pod. We have no information because the pod is actually running properly. So what's actually crashed is the application that's inside it. So that's why we can see restarts. Okay, so the pod is terminated, the container inside the pod is restarted. This is what we have here, restarted 49 seconds ago. When the application crashes, the container is restarted. During this period, the service redirect users to the available pod. So actually traffic is being redirected to simple pod, simple web app 2. Since the pod status is not ready. Let's look at the port status again. Still not ready yet. Still restarted. It's restarted actually. Okay. What will happen if the application inside container in one of the port freezes? To try this, let's try the freeze by accessing the freeze URL of the application in the browser, or run the freeze script. Let's look at the freeze script what's inside. So there is an endpoint to freeze the app. Let's run that script and let's check the state of our port again. Nothing new. So freezing doesn't mean, I think freezing is that the application is still running but it has frozen and made it in a state of wait. So what happened if it's frozen? We can see no restart, nothing has changed. What if you run the CKAD test on frozen app? All traffic is being routed to port 1. Nothing is being routed to port 2. You can see that port 2 is not ready anymore after that freezing. Before it was ready, and right now it's not ready. Okay, so what happened? The container inside the port is restarted. It's actually not restarted. Users are not impacted. The port is terminated. New users are impacted. What can I pick? Maybe this one, new users are impacted because they can't run the app that's on simple web app 2. Let's try that. Yeah, that's the right answer. Now update both the port with liveness probe using the given spec below. Update both the ports. So this is both of our ports, but I had a file for the web definition for the YAML description of port 2. We'll do the same for port 1. So kubectl get port, put the output in YAML format and redirect to web app 1.yaml. So let's start with web app 1. Oops, let's start with web app 1. We're going to add liveness prop. And we'll send HTTP GET requests to the path /live to the port 8080 and get it from here. And I'm going to save that, and I'll do the same for web app 2. After the readiness prop, let's add the liveness prop. HTTP GET request support 8080 to the path /live. We're not done the period seconds, the number of time it has to, the frequency that it has to test the liveness of the port. What is the keyword for that? It's period seconds. Yeah, like this. The same hierarchy as get request. The period second is 1, which means every 1 second or every second the pod is going to be tested to see if it's alive, it's actually in good health. Initial delay 80, this means when the pod starts we have to wait for 80 seconds to make it ready, and after 80 seconds we start testing the liveliness every second now. So I'm going to add this period seconds, not period seconds, initial delay, sorry, I did not copy. Initial delay means when the pod is started, give it like some initial delay of 80 seconds for this case, so that maybe internal processes can get ready. And period seconds, after it's ready, test the liveliness of the pod every second to see if it's still up and running correctly. I'm going to add these two values to the other one. I skipped it that way. So I'll go back to web app 2, web app 1, sorry. And add period seconds and initial delay seconds. Alright, and we're not done. I need to delete the pods that we're running and create new ones from the new configuration. So I'll delete pods with an S, I think so, and I'll give in the 2 pod names. Oops. So kubectl delete pod simple web app 1 and simple web app 2. Okay, now I need to recreate new pods. kubectl apply -f web app 1 semicolon. I'm going to do the same command for web app 2 so that the 2 pods can start at the same time. -f pod in version 1 cannot be handled as a pod strict or unknown field liveness prop. So there should be an error in typing somewhere, like liveness prop, liveness with an E here. Okay, let's save that and let's check for web app 2 if I did the same mistake. It's okay. Okay, let's recreate the pods. Pod 1 is created, pod 2 we have a conflict again. Operation cannot be fulfilled on pod simple web app 2. The object has been modified. Please apply your changes to the latest version and try again. So what pod is running? kubectl get pods. Oops, it actually started the 2. Error when applying patch. Operation cannot be fulfilled. I'm going to delete web app 2. It seemed to have an error and we'll start that one. Delete pod. This. and then I'll restart web app 2. Okay, it's created very well, and let's check this. Everything is okay. Now freeze the application again and notice what happens. I can run the freeze script, and how can we see what happens? We need to run the curl. Normally I was even supposed to wait for it to be to be ready. Okay, so now I've frozen port 2 and port 1 is running very well. So before it wasn't working because I think the 80 seconds was still running for it to start, for it to initialize, but now it's running properly. Port 1 is responding to request, but port 2 is not responding to request because I actually froze it. So users are not impacted here. Let's see the states of the ports. Okay, everything is ready. Let's rerun this. You see both ports are running now, because when you configure liveness prop, when after a certain moment when it freezes and the liveness prop detects after 3 times that it's not more working, what happens is that the port is restarted. That's what happened. It actually restarted. So that's the advantage of configuring a liveness prop. It permits the Kubernetes cluster to restart the pod when it actually freezes. If not, it would have stayed in the freezing state. That's it. And which means according to this exercise, it's actually port 1 that got frozen. So we can actually freeze again to see which one gets frozen this time. kubectl get ports. You see, we first had one restart, so let's wait for a moment and see which one gets restarted. I'm going to run the curl command. So port 1 is responding, which means it's port 2 that is frozen. So at any given point, we're supposed to have port 2 get restarted by Kubernetes. You can see port 2 is no more ready. You can see port 2 is being restarted now after being frozen by our bash script. So Kubernetes have restarted port 2 and it's waiting for it to be ready. Remember, I have to wait for 80 seconds according to, let's open the file, according to I have to wait for 80 seconds according to our, it's not even 80, we do not even configure the initial delay inside the readiness. But anyway, we configured a get request. So onto this get request /ready, This endpoint works very well. Kubernetes will not consider that the port is ready. So let's rerun the curl to see if everything is back up. Port 2 is not responding yet. Okay, now it's ready. Let's rerun that. Okay, port 2 and 1 are back up. So this is the end. Thanks for viewing, and see you on another exercise or another practice session.